Dude, I'm going to tell about speed and velocity. This cute little seal start to move towards right side, then towards downside 3 meters, and again towards left side 3 meters. It actually moved a total distance which you can calculate as equal to this one 5 plus 3 plus 3, which is 5 plus 3 is 8, and 8 plus 3, which is equal to 11 meters, and it moved this much distance in time of just 11 seconds. Now you need to calculate what is the speed and velocity. Speed is easy. It is the starting point and ending point. Whatever the total path it traced, it can be known as distance, and distance by time is speed. Speed equal to distance by time. Here they have given distance as 11 meter and time also 11 meters. So it is 11 1 times it is 1 meter per second. But the velocity changes. Velocity means it is displacement by time. Here you can find out here. If you draw any line parallel, you're going to get this line is parallel to this line, it is also 3 meters, and this line is parallel to this line, this is 3 meters, and this is 2 meters in this 5. You must find out the minimum distance between the initial and final point. So you're going to get displacement. If you get the displacement, then you can find out the velocity, because velocity is displacement by time. Here it is the minimum distance by time. Here you can calculate it in this right angle triangle. You can rewrite that right angled triangle. Here it is 2, here it is the right angle, here it is 3 units, 3 meters. And now hypotenuse square equal to 2 square plus 3 square. Here 2 square is 2 times of 2, which is equal to 4, and 3 square is 3 times of 3, which is equal to 9. So 9 plus 4, which is 13, which is the hypotenuse. Square comes this side, it becomes root. Hypotenuse is root 13 meter. So you can write displacement by time, which is root 13 by 11 seconds, that is meter per second. This is the actual velocity. Velocity will be always less than or equal to the speed. The maximum time velocity equals is maximum, it can become equal when a path is a straight line. In this straight line there is it traveled 10 meter, so there is no change in distance and displacement, so even in 5 seconds. Now this seal actually covered, which is a straight line. You can calculate here the distance. Speed is distance, which is 10 by 5 seconds, 2 meter per second, and velocity, which is displacement by time. Here displacement is also 10 meters, and here it is by 5, which is 2 meter per second. It is very rare that when it moves in a straight line without changing any direction, then only the speed and velocity can become same. Now I'm going to tell how another time the same seal now going to go in a square path. In this square path, it start to move like this one, and here it moves 10 meter towards right, and again 10 meter towards down, and again 10 meter towards the left, and 10 meter towards the upside, 10 meter towards upside, and here it is the starting point. Now you can take starting and ending point are same, starting and ending. Now we can calculate speed. First take out the distance equal to 10 plus 10 plus 10 plus 10. Now which is 10 plus 10 20, 20 plus 10 30, 30 plus 10, which is 40, which is equal to 40 meters. Speed is equal to distance by time, so it is equal to 40 meters. It covered all of this in just 10 seconds, which you can take it as time. So 10 seconds it traveled this much, that is 40 by 10, 0 cancels, 4 meter per second. Now we can calculate velocity. Velocity is even simple, displacement by time. Here displacement is actually 0, because initial point and the final point, starting and ending point, the minimum distance between them, they are the same, so displacement is 0. It is equal to 0 by 10 seconds, which is 0. 0 meter per second or just 0. And now let's take another one problem. Here not the seal, here the bird start to move. This cute little bird which was flying in the air start to move around a pole in a circular path, in a circle around the pole. And this circle it started to cover about 3/3 of a circle, and it is covering with a radius which is equal to 5 meters. 5-meter radius circle. Here there is a pole around that it covered this much distance. It is the starting point and it is the ending point. Now you can calculate the speed. You must first find out the distance, and then displacement is the minimum distance between them. Here also 5-meter radius. You need to calculate this much distance, that is the minimum distance between starting and ending point, and you can get the actual time. And now you're going to get, they have given time is equal to 5 seconds. It covered all of this in just 5 seconds. And now let's find out the speed. Let's find out first the distance. If you take a complete circle, you can take out the circumference of circle like this. Circumference of circle is 2 pi r units. But if they have given this one partial circle, like sector of a circle, just a little bit curve, or a more curve which covers about the semicircle, or a quarter of a circle, and then you must use another formula. That formula is perimeter of a curve, that is perimeter of curve is equal to the distance covered theta by 360 times of 2 pi r. Here theta is the actual angle which is swept. Here it is 30 degree, here it swept about 180 degree, and here it swept 90 degree. It covered different angles it swept. And so now here they have given 3/3 of a circle, so you can take this complete thing as equal to 270 degree. You can take as 270 degree. So here you can find out the curve, that is the perimeter of the curve. This perimeter is equal to theta by 360 times of 2 pi r. Here theta given us 270 degree by 360 times of 2 pi times of radius is 5 meters. 0 0 cancels. You can do 3 9 times, here 3 1 times, 3 2 times, again 3 3 times, 3 4 times. We're going to get 3 by 4 times of 2 pi times of 5, and here 2 1 times, 2 2 times, and you're going to get 3 times of 5 15 by 2 pi meters. The perimeter I calculated, that is the distance, is nothing but the total distance. Now you can calculate the displacement also. Displacement means you must take this smaller one, that is the triangle. If you take this triangle, now you're going to get the minimum point. Minimum distance is this one. It is right angle triangle with hypotenuse. Here also 5 meter, here also 5 meter. So you can find out hypotenuse square is equal to 5 square plus 5 square. Here 5 times of 5, which is 25, and again 5 times of 5, it is also 25. 25 plus 25, that is 50, equal to hypotenuse square. Square comes this side and it becomes hypotenuse is equal to root of 50. Again you can write it as 2 times of 25. 25 comes out, it becomes, you can write it 25 as 5 square. So if it comes out, only 5 remains. 5 root 2 meter is the actual minimum distance between the initial and the final point. So the displacement here is equal to, displacement is equal to 5 root 2 meter. Now they have given the distance, so the speed equal to distance by time. So it is 15 by 2 pi divided by 5. This 2 comes to denominator. Here you can divide 5 1 times, 5 3 times. It is 3 by 2 pi meter per second. Now displacement is this one. So velocity you can write it as equal to 5 root 2 this displacement by time 5 seconds. 5 5 cancels. Root 2 meter per second. This all thing you can write it as speed and velocity.